In order to code up the ARM version of the recursive MergeSort, the approach that I took is to convert a C program into ARM assembly by hand translating each statement. The code I obtained from the following website, geeksforgeeks.org, currently showing on the screen. Once you have this code, the first thing that you may want to do, or that we may want to do, is to run this code to make sure that it actually works, that it actually sorts out the array. Given the following array, which we can see is the array that was passed into the main function, it sorts it out. Now, another thing that we need to do here is to test it for different size arrays. So all we're going to do here is we're just going to delete a couple of elements, build, compile, and execute, and we see that it can sort an array of 3 elements, which is one of the things that can happen in the merge sort, is that the partition isn't set up correctly, and as a result you end up having an extra element when you have uneven arrays, or arrays that have an odd number of elements. Alright, the next thing that we want to do is we're going to take a look at our code to look for main sections so that we can get an idea of how this is going to compare to our ARM program. This is a recursive merge sort, so it's obviously going to have a recursive call, a recursive function, which is the merge sort function right here. Then we have, of course, our main function, which is where we pass our array, and we also have to give it the array size calculated here in the traditional way for the C language. And we also are using a helper function in the C code, the print array function, so that it displays once we print it out to the console. Now, in the main function in our ARM program, let's see here. Here we go, main. In our ARM, in the main function in an R program, we will have to create an array loop. This is what I have right here in this section. You have to create an array with random elements, and what I'm doing here is I'm calling the random function to create an array with 0 random elements from the number from 0 to 255. So the elements in the array are only going to range from 0 to 255. After that, what we do is we're going to print the array, and this is going to be similar to the print array function in the C code. We print the array to verify that all of the elements, or that we have successfully created all the elements in that array. The next thing that we have to do is that we have to set the parameters for the merge sort. This is what this section is right here. In ARM, the function call is going to take as parameters the first register, R0, R1, R2, R3, R4, R5, and possibly more, depending on how we configure our function. In this case, the MergeSort function is going to take in 3 parameters, which means that it's going to take R0, R1, and R3. That means we have to set the values of those registers to the values that we want to use for our call to that function. So the first thing we need to do here is we need to load R0 with the address of the array A, and this array is going to be defined up in the data section at the top. Next thing that we want to do is we want to put the number 0 into R1, because that's going to be our left index, the index of 0. And then the next thing we're going to do is we're going to load the right index of the array, and this is contained in our variable n, which is also defined on the top on the data section. So now we have this now that we have those values on those registers, we can make the call to the merge sort. Now notice here I have here a subtraction instruction. It says n take 1 from n and put it into R2 because that is our R parameter. And if you look at the C function on the right side, this is what they also did here. Once they calculated the array size, they don't pass the array size as a parameter, because remember that that will be one index over. It will be an array index out of bounds. So you have to pass that parameter as the array size minus 1. Just to take a quick look on the top, this is the data section. Over here we're defining, first I defined 2 strings. The first one is to print out the arrays, to see what elements are in the array, and the next one is part of the middle section of the code that just prints out the left and right index to verify that the code is working as we intended to work. Then we define our array A, and here we have to skip 512 bytes, right? Because this will be each element in the array is going to be 4 bytes. So we have to, if we were looking to create an array of 128 elements, we have to create an array of size 128 times 4. Then we have our left and right arrays, which are also part of the code in C. If you look to your right, let's see, right here on the, before we enter the first while loop on this side, we have defined 2 arrays, the left and right arrays, which is they are half the size of what the main array is going to be, or at most they're half of what the main array is going to be. And then here we have our n constant, our number of elements, and this is just a simple constant that states how many elements we have in that array. And then this is 128, and if you were to change the number of elements, you would also have to change this to whatever you like. You could change this to, for instance, 12, and then we could assemble and compile our file, and we could execute, and it will create an array of 12 elements in this instance. Now, of course, if you really wanted to create an array of only 12 elements, you would also have to change this to, instead of 512, it would be 12 times 4, and this would be 12 times 2, these 2 elements over here, in order to save space. Now let's just go back to the original problem. So once we have set up the call to the actual function, we can go into the MergeSort function, because this is the first one that we're gonna call. So here is MergeSort. What does MergeSort set? If the left index is less than the right index, then we're gonna define the middle by doing this operation, and then we're gonna call MergeSort recursively with the following parameters. So this is what I have done here on the MergeSort function. So as you can see, I have on top, I have the code in C, and then below I have the ARM equivalent of what that would be. These sections are gonna use the push and pop functions to push values into the stack and back out of the stack, so that we don't have to use all of the registers. And in some cases, this is going to be really helpful because we don't have enough registers to keep track of all of our variables. So the first part is actually very simple, because all this is doing is calling functions. The only thing that's calculated here is this m, and that's what I do here in this instruction. So we pass those parameters already. So this is R0, this is R1, and this is R2, and we also have to include the link register here so that we can restore our state once we exit the function. So first we're gonna, in this part, we're just gonna load the string 1, which, as you may remember, is what prints out the values of the indexes, so we can verify code operation. That's not really needed for the program. It's just for us to verify that the code is doing what we think it's doing, or to see what the code is doing. Now here we do the comparison, the L and the R. Obviously L is in R1 and then R is in R2. So that's what we do here, compare R1 and R2, and then go to the end, or the end of this function if L is not less than R. And again, once here we're pushing our values so that we could use those registers. This is where we make our calculation. So into R2 we're gonna have R minus L, which is R2 minus R1, because as you recall, R2 is R and R1 is L. And then we're just gonna do division using the logical shift right, and then once we have that value, we can add L into R2, and now we have our M, and then we just push back the value. I'm sorry, we push R2 in order to save that value so that we can use the R2 register for the next operations. So here we're gonna call the MergeSort after we have set up the parameters, and then here we're gonna set up the second call to the MergeSort, and as you can see, we're popping the value that was in R2, which was M, into register 3, and we're popping R1 and R2 into their corresponding registers. And all of this is so that we can set up our function call. Here we're gonna have a MergeSort call with the parameters array m+1 and R. So we're gonna put m+1 into R1, and then we're just gonna leave R as it was originally. We're doing the same thing here, again setting up this recursive call. In this case the call is going to be to the merge function. So we need to pass the array, we need to pass the left index, we need to pass the middle, and we need to pass R. But we need to be careful because R0 contains the array, R1 contains L, but R2 and R3 are originally switched before we set up the parameters for that method call. So before, you have to be really careful, or otherwise your array is not going to work. Anyway, here we call merge. Now this function we have already seen in the iterative version of the MergeSort. These are all the inner loops that are inside the two for loops, right? These functions right here. Essentially, we're just using instead of using the same array as we use, or two arrays as we do here, the A and B arrays. In this case, we're using three arrays. We're using the A array, the left array, or the L array, and the R array. So let's go up to the top and let's take a look at the merge function. Again, anytime you enter a function call, you want to push the registers that you're passing so that you can restore the state once you exit the method call. The first thing I'm going to do here is I'm just going to request labels for my variables to make my life a lot easier. So I'm going to need an int I, j, and k. So these are going to be my register 5, 6, and 7. And then I'm going to need an int n1 and n2, and those are going to be R8 and R9. And I'm pushing all of these registers onto the stack to save their state to be restored later. Here, same thing, I'm just saving M2 so that I can use the register to calculate the following value of N1. Then I calculate the value of N2, and I'm just putting these values into the registers that I requested. You see, instead of using R9 here or R8, I'm just using N1, and here instead of using R9, I'm using N2. This is pretty much the same that we have with the iterative MergeSort. After we have created our arrays in our data section, as we spoke before, the L array and the R array, those are already set up. And then in order to copy those values into those arrays, we're going to need to set out 2 for loops, and those would be equivalent with those for loops over here. After we have done that, we have all of the values on the left array. We have our values that are partitioned to be on the left side of the A array, and then on the right we should have the values that are above the M value on the A array. Once we have this, we're gonna set I equal to 0, and that's what this instruction does. Then J to 0 and K equals L, and L, as you recall, is our 1 from the value that we obtained from our original function call. And then these while loops are pretty much almost the same as the other ones, except that instead of just using the A and B arrays, I'm going to use the left and right array. So I have to change my references. It's pretty much the same code. I just have to change my references here and my registers, of course, because I'm using different registers. But it's essentially it is the same code. We do the conditional assignment. And what we're saying here is if L sub I is less or equal to R sub J, then we're putting that value into our main array, and that'll be our first swap. And same thing with the following. We copy the remaining elements if there are any. We're copying the remaining elements of R if there are any. And finally, we end the merge. And that should have, once we have gone through all of this code, it should have sorted our array. One thing to notice here is that in the recursive version, we don't need to add a for loop in the end, because we are already changing the original array that we're going to print out in the end. So we don't need this final for loop as we do here, this for m loop that pretty much copies all of the elements that we have sorted from the B array to the A array. Instead, we have already done that by copying from the left and right arrays into the original array by replacing those values. So once we have gone through all of this, we remember to pop our values, restore our state, and we can finally go to the end of our function. Once everything is said and done, we print the array one more time, and now this array should be sorted.